Children, welcome to AyaansEasyMath Olympiad. So here this is a new topic. You are going to deal with RDSharma 10th class CBSE 10th class exercise 1.1 question number 1 to 7 according to the latest edition 2022. So before going to the topic, so those who are new to this channel, subscribe the channel like this. 10th class problems, RD Sharma CBSE problems will be uploaded from this channel. So here, before going to the topic, real numbers, the heading of the chapter, real numbers. So before going to the problems, you have to know about Euclid division lemma. So Euclid division lemma is nothing but division rule. So before going to this Euclid division lemma, I want to explain by taking one example. Example I am taking dividing 22 by 4. 22 divided by 4. This you have learned in the lower classes. So here 22 when divided by 4. So here 4 5 is 20. Here you will get remainder 2. So I want 22. 22 if I want what I have to do 4 into 5 plus 2. So here this is called dividend. Dividend is equal to divisor into quotient plus remainder. So this you have learned in the lower classes. So this is nothing but Euclid division lemma. So this division rule what you are following in the lower classes. So here you will call it as Euclid division lemma. By using this property you are going to complete the problem. So here what is the definition of given positive integers a and b both are positive. There exist unique integers q and r, unique integers q and r satisfying a is equal to b q plus r. Here 0 less than or equal to r is greater than 0 less than or equal to b. So here what you are doing, you are dividing a with b, you are getting quotient r and you are getting remainder r, q times it is going. So what is the meaning of lemma? So it is a proven statement used for proving another statement. So that you will call it as division lemma. So now we are going to deal with exercise 1. Exercise 1.1. Question number 1 to question number 7. Basing on this division lemma. So here we'll start. So the first question is given. Prove that the product of two consecutive positive integers is divisible by 2. So here we have to take a solution. Let n and n plus 1 are two consecutive positive integers. Two consecutive positive integers. So here it is divisible by 2 by using Euclid division lemma. N is in the form n equal to 2q, and n plus 1 will be in the form 2q plus 1. Now he is asking to find the product. N into n plus 1, we are finding the product now. 2q into 2q plus 1. So here 2 you are taking common, sending q inside, 2q square plus q. So here 2 is common, you can say, therefore which is divisible by 2. Which is divisible by 2. Now if we take the second case, if n is equal to 2q plus 1, then n plus 1 will be 2q plus 1 plus 1, that is 2q plus 2. Now their product n into n plus 1 is equal to 2q plus 1 into 2q plus 1 plus 1. So here you can write 2q plus 1 into 2q plus 2. So here also you can take 2 common in the second case. 2 into 2q plus 1 into q plus 1. So which is divisible by 2. Which is divisible by 2. By this you can say, therefore the product of two consecutive positive integers is divisible by 2. This is the first solution. Now we'll go to the second problem. Here the problem is given now. Prove that the product of three consecutive positive integers are divisible by 6. So here let n plus 1, n plus 2 are three consecutive integers. Consecutive means the integers which are side by side, like 4, 5, 6. So it should be divisible by 6. So in Euclid lemma, our b value is 6. So r value should be in between 0 and b. So r value will be 0, 1, 2, 3, 4, 5. Now he is asking to find the product of three consecutive integers, n into n plus 1 into n plus 2. So here if you multiply first 2, n square into n, here n plus 2. Now you will take case 1. Case 1 r value 0, then n will be 6q. So here their product n into n plus 1 into n plus 2 is equal to 6q plus 1, n plus 1 6q plus 2. So here 6 is outside, which is common for all, which is divisible by 6. Which is divisible by 6. Now if you take case 2, So like this we will get 6 cases. So here we are taking first 3 cases and then we will confirm r is equal to 1, n is equal to 6q plus 1. So n into n plus 1 into n plus 2. So here we will get 6q plus 1 bracket 6q plus 1 bracket 6q plus 1 plus 2. So here what will get here 6q plus 1 into 6q plus 2 and 6q plus 3. So here 6q plus 1 here you can take 2 common. So if you take 2 common 3q plus 1, here you can take 3 common. Here you can take 3 common. So here what will get 2q plus 1. So here if you multiply these two, you will get 6 into 6q plus 1 into 3q plus 1 into 2q plus 1. So here also it is divisible by, which is divisible by 6. Okay. Now if you take the third case, case 3. So r value 2, n is equal to 6q plus 2. Now n into n plus 1 into n plus 2 is equal to 6q plus 2, 6q plus 2 plus 1, 6q plus 2 plus 2. So the product what will get here? So from this you can take 2 common, 3q plus 1. From this you can take 3 common, 2q plus 1. Here 6q plus 4. So here 3 into 2 you will get 6. 3q plus 1, 2q plus 1, 6q plus 4. So here 6 is common here. So which is divisible by 6. Okay, similarly you can show all the remaining 3. So therefore the product of 3 consecutive integers is divisible by 6. Now we'll go to the next problem. Problem number 3. Show that the positive odd integer is of the form 6q or 6q plus 3 or 6q plus 5. So here the solution, let a be any positive odd integer. Here b value is 6, divisible by 6. Okay, here 6 is given, so you are taking b value 6. So according to Euclid division lemma, so here b value is 6. Then a value is 6q plus r. So this r will be in between 0 and b. R value 0, 1, 2, 3, 4, 5. So here when you take r value 0, where r equal to 0, then a value will be 6q. When a value is 1, r value is 1, a is equal to 6q plus 1. when r value 2, a is equal to 6q plus 2. When r is equal to 3, a is equal to 6q plus 3. When r is equal to 4, a is equal to 6q plus 4. When r is equal to 5, a is equal to 6q plus 5. So here you can see this is a divisible by 2, this is not divisible by 2, this is divisible by 2, this is not divisible by 2, this is divisible by 2, this is not divisible by 2. So therefore I can say this value is odd. This is also odd, a value. This is also odd. Therefore, positive odd integers is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. This is the solution for third question. Now if you go to the fourth question, show that one and only one n plus 1 and n plus 2 is divisible by 3, where n is a positive integer. So here the solution. So here let n is a positive integer. N is a positive integer. Here b value is 3. N is equal to 3q plus r, where q is some integer. So here the value of r lies between 0 and b. So r value 0, 1, 2. So when r is equal to 0, n is equal to 3q. When r is equal to 1, n is equal to 3q plus 1. When r is equal to 2, n is equal to 3q plus 2. So this is a divisible by 3. This is not divisible by 3. This is not divisible by 3. Only one value is divisible by 3. When r is equal to 0 for n plus 1. N plus 1 is equal to 3q plus 1. When r is equal to 1, n plus 1 is equal to 3q plus 1 plus 1, 3q plus 2. When r is equal to 2, r plus 1 is equal to 3q plus 1 plus 2. So 3q plus 3. Now this is not divisible by 3. This is also not divisible by 3. Only this value is divisible by 3. Now if you go to the third case, for n equal to n plus 2, n equal to n for n plus 2, when r equal to 0, n plus 2 is equal to 3q plus 2. 3q plus 2. When r is equal to 1, n plus 2 is equal to 3q plus 2 plus 2. Okay, when r is equal to 2, sorry, here 1 now. So 3q plus 2 plus 2. So here you can get 3q plus 3. This is divisible by 3. This is not divisible by 3. This is not divisible by 3. From this 3, we can say, therefore, 1 and only 1, 1 and only 1 of n plus 1, n plus 2 is divisible by 3. This is question number 4. Question number 5. This is somewhat very small question. Question number 5. Let show that the square of an odd integer is of the form 8q plus 1 for some integer q. Let n is any positive odd integer. Any positive odd integer. So n will be equal to 4p plus 1, where p is some integer. Where p is some integer. Now squaring on both sides, n square is equal to 4p plus 1 whole square. So here you are using a plus b whole square formula. A square plus b square plus 2ab. N square is equal to 16p square plus 8p plus 1 now. So n square is equal to, here you can take 8 common. Okay, 2p square plus p plus 1. So let 2p square plus p is equal to q. Q is some integer, some value of the integer. Then it will be in the form of 8q plus 1. The square of, therefore, the square of an odd integer is of the form of 8q plus 1. This is the question number 5. Now if you go to question number 6, the square of any positive integer is of the form 4q or 4q plus 1 for some integer q. So here let a be any positive integer and b is equal to 2. According to Euclid division lemma, a is equal to 2m plus r, where m is any integer. M is any integer. Okay, the value of r lies between 0 and b. So r value is 0 and 1. Why? Because here b value 2. So when r is equal to 0, a value is equal to 2m. R value 0, a value is 2m. Squaring on both sides, a square is equal to 4m square. So let m square is equal to q. So for q is any integer. So here a square is equal to, what you are getting, a square is equal to 4q. Now when r is equal to 1, then a is 2m plus 1. A is 2m plus 1, squaring on both sides. 2m plus 1 whole square. A square is equal to 4m square plus 4m plus 1. In the previous problem we have seen a plus b whole square formula. A square plus b square plus 2ab. 4m common, 4 common, m square plus m plus 1. So here m square plus m, you are taking any q as integer, any integer. So here we will get 4q plus 1. Therefore, the square of any positive integer is of the form 4q or 4q plus 1. Now we will go to the last question number 7. After this we will conclude. For any positive integer n, prove that n cube minus n is divisible by 6. So here let n is any positive integer. N will be 6q plus r. Q is some integer. Okay, r value is 0 less than or less than b. B value 6 here. R is 0, 1, 2, 3, 4, 5. So here we will take 3 cases. First case, r is equal to 0. N will be 6q. So n cube minus n is equal to 6 cube minus 6q. So here 6q can take common. 6q square minus 1. So here which is divisible by, here 6 is there, which is divisible by 6. This is case 1 now. If you take case 2, so like this total 6 cases will get. So r is equal to 1, n is equal to 6q plus 1, n cube minus n is equal to 6q plus 1 whole cube minus 6q plus 1. Now if you open the bracket, 216 6 cube plus 108 q square plus 18q plus 1 minus 6q minus 1. Plus 1 minus 1 cancel. So here we will get 216 q power 3, 108 q square plus 12q. Okay, 18q. Okay, 12q. 18 minus 6, 12q will get. Here you can take 6 common. So 36 q power 3 plus 18 q square plus 2q. So which is divisible by 6. Now case 3, r is equal to 2, n is equal to 6q plus 2. N cube minus n equal to 6q plus 2 whole square minus 6q plus 2. If you expand this, 216q cube plus 216q square 72q plus 8 minus 6 cube minus 2. So 216 cube power 3, 216 q square plus 66 q plus 6. Here also you can take 6 common. So 36 q power 3, 36 q square plus 11q plus 1 now, which is divisible by 6. Therefore, any positive integer n, if you take n cube minus n, is divisible by, remaining three cases are there, you can get it, is divisible by 6. I hope you like the video. If you like the video, subscribe the video and share the video to your friends. Thank you for watching. AyaansEasyMath.